Okay, class, this is our last unit of the year, so we're going to be split up by Thanksgiving. So this unit is all about exponents, and then we'll have a couple of units starting out after Christmas that deal with the same concept. Okay, so today is just a review of exponents, properties of exponents, things you should have seen before, but things that are pretty basic for exponents. I don't mean to say it's easy, but like these are base properties that you got to have in place. So basic in the sense that they have to be solid to build upon. Okay. The graphic here, I sort of like this. You know, this is what's on the page, and then sometimes what students see. So anyway, our goal is to make everything as clear as what you see on the left, and if you're seeing any kind of confusion, which is on the right, to try to clear that up. So let's start. Basic properties of exponents. Okay. Anytime I have two expressions that are multiplied, okay, the exponents are added together. So a to the m times a to the m, this is a to the m plus n. You add the exponents. So if I had 5 squared and 5 to the 4th, this is 5 to the 6th. You add those exponents together, okay? Just under that, and this is where sometimes people get the two of these confused, if I have a to the m and I raise that to the nth power, this is a to the m times n power. These exponents are multiplied. So for example, if I had 2 squared and I raise all of that to the 4th power, that's 2 to the 2 times 4. That is 2 to the 8th power. So the exponents are multiplied. So again, if I'm multiplying two expressions, each with their own exponent, I add the exponents. If I have something raised to an exponent and I raise it yet to another power, I multiply those exponents. When it comes to division, a to the m over a to the m, this is a to the m minus n. Okay, so these exponents are subtracted. Another way of doing this is I could write this as 1 over a to the n minus m. So with division, you do subtraction of the exponents. If I do the subtraction m minus n, my answer stays in the top of the fraction. If I do n minus n, my answer stays in the bottom of the fraction. So if I had something like 5 to the 7th over 5 to the 5th, that is 5 to the 7 minus 5. That's 5 squared, or 25. If I had 2 to the 4th divided by 2 to the 7th, that's 1 over 2 to the 7 minus 4. That's 1 over 2 cubed, which is 1 over 8. 2 times 2 times 2. Fractional exponents. If I have a to the 1 over n, okay, another way of thinking about this means the nth root of a. Now we've dealt with this before. Remember when we were graphing? Remember how we graphed, x to the 1/3? That was the graph of something. Pardon me. That was the graph of something that looked like this. Okay, that was x to the 1/3. We said that this is the same thing as saying the cube root of x. Okay, those are the same expressions. Okay, so 8 to the 1/3. That's the same thing as the cube root of 8. What number can you multiply 3 times and get an 8? That number is 2. And when we have fractional exponents like a to the m over n, the way you need to think about this, if you've got a to the m over n, whatever's on the bottom here, this is always your root, okay? And then you're raising it to the power of what's on the top. So this is the nth power, and it's the nth root, okay? So the way to think about this is the a to the m over n is the nth root of a to the m. Okay, so you can write this is the nth root of a to the m, or the nth root of a raised to the m. It doesn't matter, okay, either of those expressions, but it's the bottom of that fraction is the root, the top of that fraction is my exponent. The other thing is with negative exponents, okay? Negative exponents, the rule is to make a negative exponent positive, wherever you find that exponent, like if I find it in the top of the fraction and it's negative, I move it to the bottom of a fraction to make it positive. If it's in the bottom of a fraction and negative, I move it to the top to make it a positive. So for example, if I had 2 to the negative 2, there is a negative exponent. It is in the top of a fraction. To make it positive, I move it to the bottom of the fraction. So that's what this is, okay? So wherever you find the negative exponent, I found it in the top of a fraction. It became positive when I moved it to the bottom of a fraction. Likewise, if I had 1 over 3 to the negative 2, there is a negative exponent in the bottom of a fraction. I can make that positive by moving it to the top of the fraction, okay? So let's work through a few examples of this, and let's see what we come up with. So negative 5 in parentheses squared. So if I look at this exponent, the exponent is a 2. It applies to what is immediate to the left. Immediate to the left of that exponent is parentheses negative 5. So what is being squared here? This is negative 5 being multiplied by negative 5. This answer is 25. And the next one, what is immediately to the left of the exponent is a 5. So this is 5 times 5, which is 25. Now, let's look at the next one. Keep in mind that there's a big difference between this problem and this problem, okay? And you got to make sure that you don't fall prey to any kind of confusion here. What is immediately left of this exponent is a 5, okay? And then to the left of that is a negative, okay? So the first thing I see left of that is a 5. So this is negative of 5 times 5. Only the 5 is being squared. If the negative 5 were being squared, it would look like you see in that first problem. So this answer right here is negative 25. So let's look at the next one. What is being squared? Negative 5 is being squared, and there's also another negative in front. So this is the negative of negative 5 times negative 5. So this is the negative of 25. So the final answer is negative 25. So looking at the next one, it's 27 to the 2/3. Okay, the bottom of the fraction is the root. So this is the cube root of 27. I'm going to get that number, and I'm going to square it. Top of the fraction is your power or your exponent. So what is the cube root of 27? What number can I multiply by itself 3 times and get a 27? This is going to be 3 squared, and we know that 3 squared is 9. The next one, negative 27 to the 2/3. So this is the cube root of negative 27, and I'm going to square that. So what's the cube root of negative 27? What number can I multiply by itself 3 times and get a negative 27? That's going to be negative 3, because negative 3 times negative 3 times negative 3 is negative 27. So this tells me this is negative 3 squared, which is negative 3 times negative 3, which is 9. Negative 27 to the 2/3. Now this one, there's a difference. The one we just worked had negative 27 in parentheses. This one is the negative of 27 to the 2/3. So this is negative cube root 27 That is squared. So the negative is not being raised to the second power. So what is the cube root of 27? That's 3. So this is negative 3 squared, which is negative 9. 5 to the negative 2. Okay, so this is 5 to the negative 2. I've got a negative exponent in the top of a fraction. I can make that exponent positive by putting it in the bottom of a fraction. So this is 1 over 5 squared, which is just 1 over 25. 2/3 to the negative 3 power. Okay, so it may help to think of this as this is 2 to the negative 3 over 3 to the negative 3. Okay, continuing on here, 4 to the 7th over 4 to the 5th. So this is going to be 4 to the 7 minus 5, which is 4 squared. This number is 16. Okay. Now this one I can do a couple ways. I can say this is 4 to the 5 minus 7. That's 4 to the negative 2. I've got a negative exponent. It's a negative exponent in the top of a fraction. That will become a positive exponent in the bottom of the fraction. So that's 1 over 16. The other way to do this problem is to just say, well, this is 1 over 4 to the 7 minus 5, which is 1 over 4 squared, which is 1 over 16. 1/64 to the negative 1/3, okay? With fractions, so like if I have a fraction like this, I could just rewrite this as, okay, a couple of things. I can write this as 1 to the negative 1/3 over 64 to the negative 1/3. Those are both negative fractions. They become positive when they switch places, okay? So another way to recognize this is just, I could just flip that entire fraction and write that as 64 over 1 to the 1/3. That means cube root of 64 over the cube root of 1. What number can you multiply 3 times and get a 64? That's 4 times 4 times 4. Cube root of 1 is 1. So this answer is simply 4. So let's do some operations here. I've got multiple things that are raised to exponents. So this is a to the 5 times 2, b to the 3 times 2. This is a to the 10th, b to the 6th, okay? In the next one, I've got 5x to the 6 times 2. Remember, the 5 is not being squared, just the x to the 6. So this is 5x to the 12th. Now in the next one, I see what's being squared is the 5 and the x to the 6. So this is 5 squared x to the 6 times 2. This is 25x to the 12th. And the next one, things are being squared. So this is 5 squared x to the negative 6 times 2. So that's 25x to the negative 12th. I don't want a negative fraction, a negative exponent. So it looks like I've got a negative exponent in the top of a fraction. That will become a positive exponent by simply moving it to the bottom of the fraction. Okay, this one, just testing to make sure that you are paying attention. A plus b cubed squared, okay? This is not a squared plus b cubed. So it's not this. Remember, this is a plus b cubed times a plus b cubed, okay? You FOIL this. This is a squared plus ab cubed plus ab cubed plus b cubed times b cubed. So this is a squared plus 2ab cubed plus b to the 3 plus 3. So that's a squared plus 2ab cubed plus b to the 6th. Okay? A to the 7th over a to the negative 4. There are multiple ways of getting to this. You could just say, let's write this as a to the 7th times a to the 4th. Let's move that negative exponent from the bottom of the fraction to the top. This becomes a to the 7 plus 4. This is a to the 11th. Okay. The other way of doing this is just say, well, this is a to the 7 minus negative 4. Okay, which is a to the 7 plus 4, which is a to the 11. As long as you obey the rules of exponents, you may take a different path, but you'll get to the same answer. So simplify these expressions, leaving no negative exponents. So what I have in the first one here, this is the cube root of 27 plus the cube root of 8. All of that is squared. What's the cube root of 27? What number can multiply 3 times and give me a 27? That's 3. Cube root of 8, that's 2. This is 3 plus 2 squared. What's 3 plus 2? That's 5. This number is 25. Now the next kind here, I know we haven't seen anything this complicated, but you got to power through this and just realize, okay, I've got x, y's, and z's. Let me just obey the exponent laws with each of these. So I've got one strategy some people like is just let's get rid of all negative exponents. Okay, so to get rid of negative exponents, xy cubed, that z to the 4th moves to the bottom. Look at the bottom of the fraction, that x to the negative 1 becomes an x1 up top. Y squared, that z to the negative 2 is a z squared up top. Okay, that may help. And then I can look and see, I'm going to go off to the right or below here. This x's, so I look at my x's, that's x to the 2 plus 1. That's x cubed, y cubed, z squared over z to the 4th, y squared. Let's take care of the y's. So this is x cubed. I've got y cubed over y squared. So that's y to the 3 minus 2. Okay. And then if I look at the z's, on the bottom of this, I've got this is z to the 4 minus 2. Okay. So this becomes x cubed y over z squared. Okay, a little complicated, but you're just obeying the rules of exponents with each of the different expressions you have. Looking at number 9 here, excuse me, the one that has a 9 in front of it. This is 9. What's being raised to the 2nd power? It's everything in parentheses. Excuse me, it's raised to the negative 2 power. Why don't I write it on the bottom of the fraction? And now it's raised to the positive 2 power. Okay, and then I just simply need to evaluate this. Everything is being squared, so this is 9. 3 squared on the bottom, that's 9. A to the 2 times 2, that's a to the 4th. And b to the 3 times 2, that's b to the 6th. Well, I've got 9 over 9, that's 1. This answer is simply 1 over a to the 4th, b to the 6th. (64 over 27 to the negative 1/3). So anytime you have a fraction raised to a negative exponent, you can just flip that fraction, and now this exponent is positive. So this is 27 over 64 to the positive 1/3. So this is the cube root of 27 over the cube root of 64. Cube root of 27, that's 3. Cube root of 64 is 4. So that answer is 3/4. This next one, please don't do this. That is just wrong, okay? I hate to even write that down, okay? You can't just get cancel happy here with your exponents, okay? What do I see? This is x squared. What happens? I've got an x to the negative 2 in the bottom of the fraction. If I move that to the top of the fraction, that becomes an x to the positive 2. This is x to the 2 plus 2. This is x to the 4th. Okay. The next one says convert this to an exponent form. Remember the nth root of a to the n can be written like this. The bottom of that fraction is always your root. The top of the fraction is your power. So this is, if I think about this, this is xy squared raised to what power? That's just the 1/7, okay? That's written in exponent form. You could leave the answer like that, or you could say it's x to the 1/7, y to the 2/7. Either way, either of these answers would be good, okay? So that should take us about the end of this. So here's the deal. You're going to have to spend time with this. There is no substitute. Don't get confused. When you're multiplying expressions with exponents, the exponents are added. When you have an exponent and you're raising it yet to another exponent, you multiply those exponents. When you have division, that's where you subtract the fractions, the exponents. Anytime you have a negative exponent, here's the rule. Wherever you find it, you make it positive by moving it where it's not. So for example, in this first one, there's an a to the negative 2 in the top of a fraction. By top of a fraction, I mean that is in the numerator. I can flip that around and it becomes a positive when it moves to the denominator. Same thing here. I see a negative exponent in the denominator. I make it positive by moving it to the numerator. And then the last thing is the relationship between exponents and radicals, the nth root of a to the n, or the nth root of a, writing that as a fractional exponent.